Okay, so at this point in the lecture, we already know what ionic compounds are. If you don't already, you should probably simply watch the video on naming and forming ionic compounds and then come back to this lesson. However, ionic compounds are comprised of a cation plus an anion. And obviously they're made up of ions, that's why it's called an ionic compound. And in general, we say that the cation comes from a metal with the anion coming from a nonmetal. Now, these ionic compounds are formed by transferring electrons, and this transfer goes in a very simple manner. The metal, which is going to lose electrons, will donate those over to the nonmetal, which gains electrons. So ionic compounds are made when a metal transfers its electrons over to a nonmetal. Now we're going to get into a different type of compound known as a covalent compound. And this is a linkage between two nonmetals this time. So previously we were working entirely with metals and nonmetals. Now we are exclusively functioning with two nonmetals. Now, when covalent compounds are formed and these nonmetals are linked together, they're not going to be connected by transferring electrons. They're going to be connected by sharing electrons. So as opposed to one element hogging all the electrons, these are going to end up sharing the electrons. Remember, for an ionic compound, the cation gives away all of its electrons, and the anion takes them all in. So the anion is essentially hogging these all. Meanwhile, for a covalent compound, it's very different. For a covalent compound, those two nonmetals are simply just going to share those two electrons at the same exact time. To look at some examples of some covalent compounds, we have first up hydrogen gas. Hydrogen is obviously a nonmetal, so when you connect two hydrogens together, it'll be a covalent compound. A very similar looking structure, bromine. Bromine is a nonmetal, and so when you connect two bromines together, it will form a covalent compound. This is something known as carbon monoxide. It's one carbon and one oxygen. As you can see, carbon is a nonmetal, as is oxygen. Same thing for carbon dioxide. The only difference is you've added an additional oxygen going from carbon monoxide to carbon dioxide. And lastly, we have a super dangerous chemical known as dihydrogen monoxide, very clear and dangerous to the touch overall. If you do not know how to identify what your metals and nonmetals are, make sure that you're looking at a periodic table and make sure that you have this line written on it. So you start at boron and you basically fill or build a staircase this way. Now, anything to the right of this line is going to act non-metallic in nature, and anything to the left of this line is going to act as a metal in nature. Obviously, there's the metalloids here in the center, but as long as it's to the right of the line, it will primarily act as a non-metal. What this means is the only things that can possibly make covalent compounds are these elements right here, plus hydrogen, obviously. All of the other elements, those to the left of this line, are not going to be able to make covalent bonds, because remember, a covalent compound is entirely between two nonmetals. Now, due to these being formed differently from ionic compounds, there are going to be some slightly different names when naming covalent compounds. So first of all, this one's similar to ionic compounds. You write the names of the elements in the order in which they're listed. So if you have an ionic compound covalent compound, like let's say carbon monoxide, CO, the name is going to go carbon first and then oxygen. You're not just going to randomly say oxygen and then carbon. Next up, in order to identify the amount of each atom in the compound, you're going to use what's known as a prefix. And the prefixes are listed on this table right here. So when you have one atom of a specific element, the prefix will be mono. When you have 2 atoms of a specific element, the prefix will be di. When you have 3 atoms of a specific element, it will be tri, so on and so forth. So whatever number you see in the subscript position, you will copy that prefix down. However, there is one exception to this rule, and that's simply that if the very first element has 1 atom, or just an invisible subscript 1, the mono prefix is dropped. So what that means is, in an example like CO, carbon would obviously be the first element, and you only have 1 atom of it. So you would not say monocarbon in this case, you would simply just say carbon. You drop that mono prefix. For the oxygen, you would say monoxide because it is not the first element. It is the second one listed in this formula. And then the next rule is exactly like ionic compounds. The second element will have its suffix changed to IDE. Very similar to ionic compounds. The element to the right will always have its ending changed to this "ide" ending. I basically already went through an example. We can do another one, CO2. So when following the rules, first of all, you should look and see the order in which the elements are listed. So first is carbon, then oxygen, which means that when you are naming this, you're going to go with carbon first, followed by oxygen. Then all you need to do is look at the subscripts and see how many of each atom there is. For carbon, there's an invisible 1 under it, so that would be 1 atom of it, and for oxygen, there's a 2 under it, so that would be 2 oxygens. And the very last thing that you have to do is make sure to change the oxygen to oxide. Now let's just go ahead and add our prefixes to the mix. So since we have 1 carbon, it would be monocarbon. And since we have 2 oxygens, it would be di, and remember that the second one has its ending changed to oxide. However, if you notice, I am kind of ignoring my rule right now, and I should fix that. Since carbon is the first element, I have to drop that mono prefix. So this would not be monocarbon dioxide, this would simply be carbon dioxide. Here's it written in the slides themselves. So now I want you to go ahead and take a quick second and look at the periodic table along with the prefix table that we had in the last slide and try to answer these questions. Okay, that probably should have been enough time for you to pause the video and give these a shot. So let's go ahead and start naming these. So for CO, both of these are nonmetals. It goes carbon, then oxygen. So we're obviously going to name it like that. For CO, you have 1 carbon atom and you have 1 oxygen atom. The prefix for 1 is just mono. So that means the name for this is going to be carbon monoxide. Remember, since carbon is the first one that's listed, you do not write down the name of it, and it'd be monoxide. Again, since carbon is the first one, you drop that mono prefix. Cl2O8, that's 2 chlorines and 8 oxygens. So this would be dichlorine, oxide. I'll just speed run through these last ones. P3Br5 is going to be triphosphorus pentabromide. Again, notice how only the second one is having its ending changed. ISE4 will be iodine tetraselenide. And here's that big scary chemical again. This is H2O or dihydrogen because there's 2 hydrogens, and monoxide because there's 1 oxygen. If you notice, the mono was not dropped here since oxygen is the second element. And that'll do it for today. Make sure you keep on studying and make sure to know the difference between covalent and ionic compounds.